Welcome to AGO Environmental, and thank you for having me. It's also AGOfuelcells.com. Some people may know about that, but in the past. Main products in the mechanical area are portable winch systems for harsh environments, and that actually goes back to 1973 when I was working on the development of training EN systems for with a new method in geophysics for borehole and surface exploration for ore bodies. One of the first winch systems that we had built at that time and continue to build it is the one right here in the mining industry, where it's called PIDO3, and that's the left side of the screen. On the right side of the screen, the yellow thing you see there is their borehole. And they've been selling since the mid-70s till now, and they haven't changed much. This is an example of what you can find. This comes from my own personal gold mine in Ontario, where arsenopyrite, which holds gold in it, and the fluorite deposits all in the same place. And this led to the development later in life, when I was in space physics, of the development of magnetic systems. Our equipment used by the military for side scan systems is seen here, and a lot of it was used in the mid 2000s for finding 40-foot wind farms off of Europe, and they didn't really want to be drilling into unexploded ordnances all around England and America. Relocating the unexploded ordnance satellite, and also the other application of hunting down submarines. In the marine group, which is in the Arctic, and again, you can see a little portable PID there on the side. It's doing CPD surveys and water sampling. You can see here. This one here is an aerospace system that was being used to test out a laser drilling machine to go to Europa look for light. Here, we'll get here. Basically, we developed a series of winches called the Altogether Winches series, and CSW10 is the largest one that we do. With distance and drums, you have an idea of the size. There's a lathe beside it. It's about 4 foot square, roughly. And these machines typically are doing jobs where they're going down 1,000 meters plus up to 3,000 meters. We have CE approved wiring of our systems, and this is that particular control system being put together. Going down several thousand meters using a Rockland BMP 500. Parts Canada on a Franklin expedition using our CSW6, and it's visible on CBC News quite often. And they'd be leaning on it, so they were showing them around, and they were running a side scan. A movie was done called The Hunt for the Arctic Ghost Ship, and at about 30 minutes in, you get to see the Franklin discovery, and this is one of the other ones putting down to cameras afterwards. Again, another Rockland system on one of our small winches, one of the BMP systems. This is an older CSW7 with a client side scan, and there it's being used by the U.S. Navy and the Canadian Navy both. was an interesting call from them where they called up one day. Is this the company that builds winches with handles? Where? And they've been using them ever since. That's about around 2000 roughly. Here you have is W7, which I went off to Greenland to service last June for the University of New York, and also to assist on getting the rest of the systems ready for doing surveying of the outflows of water from the ice sheets and from the glaciers as they were melting. And this was on the west coast. And then after that, we have another trip, it's on the east coast of Greenland. We're doing the same thing. With a ship that they were going to put it on and go out with. And this is a local community. And every day, it was always sun 24 hours a day. The temperature was always 4 degrees centigrade. Here you have Dr. David Holland, who was also the one in Greenland, unloading our PIDO2 winch system in Antarctica on the Doomsday Glacier. Here, they were checking the water temperature of the outflows coming from the glacier and finding it's heating up over the ice, causing it to melt faster. So it was quite a surprising discovery for them. But the box is carrying it out, sliding down the ice and about to use it. This was built by Sea Sciences, the Code Acrobat unit. It was the very first company to use our unit, and they developed CSW6 back about, I guess, probably about 1990 and 1987, somewhere in that area. And they've been using them ever since as well, selling them with those systems. It's a remotely operated targeting unit, and that's self-explanatory. It's being used in England, and it's around, and somebody's shooting at it. So that one's for. And we have other clients that are coming on from the more on remotely operated approach and so on. Some of our other projects like pressure cases, slip rings, wire connection that you've seen previous, subsea connection and cabling, and titanium pressure cases, battery packs going all the way 4,000 meters. This is a 10-inch diameter titanium case being bored out, or this one ended up down in the Gulf of Mexico. Here you have a laser particle counter. It shoots a laser beam across back and forth and measures the particles in the water column. This is that particular 10-inch titanium pressure case. Here you have one of our slip rings, so if you have an issue, you open it up and you change the inside if there's any problem. So far, we've only ever been done in 20 years. Our mechanical boring counter on the left side and a snatch block and EWC electronic wire on the right side. That was originally developed for national defense in 1986. This is the updated version of it here. And this particular winch here is the EW3. We're introducing into it an encoding system from the ground, and it measures the cable distance out plus the speed and displays it all and sends it off to the local computer. And this particular winch is holding 4,000 meters of case. These will be used for hydrogen. Okay. By popular demand, Sting Systems is about to return. That stands for Seabed Terminal Impact Newton Gradiometer. And you'll see a picture of it in a moment. We built subsea lasers, red, green, and violet. Yeah. We used to do cameras, not so much anymore. And same thing, lights, you don't bother that much with it. And also in the EV boat projects. So this is the sting system here. You drop it, it goes into the seafloor up to approximately 3 meters depth and calculates the bearing strength of materials. And that tells you from the military, where mines can hide, smart mines now, hide mud for the ships, so back and ready to go. Or just used on calculating what beach you want to on. But I think that's on the strength and capabilities of the materials that you're dealing with. A version that was also sent to one of the moons of Jupiter by the European Space Agency.
Hey Jim, can you hear me?
Yes.
Any chance you might be in an office and you could maybe close your door? We're hearing a lot of I guess we'll call them shop sounds. It sounds like people are very busy there, so that's a good sound. But
well, unfortunately, I don't have an office.
It's because you are in the shop. Sorry.
We can stop.
Yeah, we can stop.
Yeah, it's late.
We got it in. We got the drum in that circle.
Actually, I'm going to show you this. This is what they've been putting together. What we were wondering what the noise was all about. And
cool.
This is one of the CSW 10s. And this one's again headed off to Geospectrum for one of their systems. And we have another one that we'll be doing in a couple of weeks that'll be going to another company on the East Coast. And if you look down that winch with the drill inside of it, that's headed off to the University of Washington. They finally decided to get a backup winch. They've been using them since the late 1980s to early 1990s on their buoy projects. They have roughly, I think, 10 of them that they have parked out on the ocean. They're doing various monitoring. And this other little one down here, that's a DBW6 being put together, headed off down to Newfoundland for subsea. They use it with their camera systems. And then there's a couple, oh, right. This particular unit here is in from Dubai, and it's here to have electric level line repairs and drive repairs. And again, they get a little bit complicated. I don't know if you can see inside of that or not.
Yep.
Yeah. But there's a lot going on.
Yeah, absolutely. No, that's cool. I guess would you say that most of your winches are for marine/ocean technology applications? No.
Actually, I'll go on here and you'll start seeing some of the other applications.
Okay.
Your sales have been marine related.
Yeah, a lot of it is marine related. This particular picture here is some of the experimental work I was doing with lasers, where I have two green lasers on the outside and a UV laser in the center. And in the picture on the right, at the bottom, you see a little red dot. The UV changed for red because the plant that it hit was doing photosynthesis. So it helped to determine that. This is a device that I designed back in the mid-1970s. We still sell them. It's a porous pot and it's good for finding gold. We sold an awful lot of them in China. One of our little drop camera systems. Again, one of our camera systems that was on PBS pole net, going down quite deep. We did high definition cameras for the Newt suit we used off of China. The little towed body up in Hudson's Bay. This is Rick Lindman's unit, one of the Mr. Toad systems, which he used a lot for doing coastal surveying around the West. This particular unit with the Bioness had a multiple netting system on it where they net, they set them off whenever they needed them. And interstitial fluid sampler, which is lowered into the seafloor, into the sediments. It extracts fluids, injects fluids, and you can do a lot of in situ experimentation. Now, coming in another part of it, the high flux telescope from Ulysses, the which is a project that I was involved with. 17-year mission was what the length of it ended up being. It was supposed to be 5 years, and it was supposed to leave the solar system. But when the unit got to Jupiter, our high flux telescope detected some anomalies, and all the information was immediately classified, and no one was allowed to discuss it. A whole lot of arguments broke out, and in the end, the Americans spent $1.2 billion on the Juno spacecraft to follow up what it did find. I have my own theories on it, and hopefully they're wrong. Anyway, the Europa project with the PID-05 winch, with laser drilling for testing for life, we just mentioned that a few minutes ago. There's another application for our winches in the reflective, the LER telescope. Okay, so there's.
Hey, Jim, just before you go on there, so this Europa winch, you essentially pass this off to NASA, and then they added the instrumentation to it. Is that right?
No, we're going to come to that.
Oh, okay.
Yeah, there you go. That's done by Stone Aerospace in Texas. Our system is being used to test out the overall idea and concept of sending the big winch, and it had a real issues in the fact that it had to be super slow, which actually sounds like it wouldn't be a big deal, but it turned out to be a very difficult thing to do. And it also had to be able to sense the loads on it, and it was like only doing millimeters per minute to allow the laser to burn a hole through the ice, and then after it would complete the drilling, they would lower down a little ROV and go down and see what they could find. The particular unit that we did build, rather large, and to go for what they want to do, it's going to be even larger. So we had to make it extremely light. So a lot of it was made out of plastics and aluminum. The NRC LER telescope system, it was actually on Discovery Channel, and here it is here going up, and it would have the focal point of the telescope up in the air, and big hunks of cement moved in order to direct the microwaves to it. Again, here's an aerostat winch here. So in other words, we're into the aerostat business too. This here is in Iraq, and on that hill in the background is where the Yazidis were with the ISIS group around, and when this went up, the ISIS guys left. I watched it all happen on Al Jazeera that day. It was rather interesting, but this is the photograph that the client sent me from there. For Neptune, here you go, thermal array system built here. This is, again, basically quite similar to the one, to the Europa one, but this was done for De Beers for looking for diamonds. So, and that's mostly in the Yukon and areas like that. And what it was is testing out that permafrost effects in the boreholes from drilling into the permafrost to see what kind of effect it would have. So they bought a whole bunch of these winches and unloaded them off into these boreholes and then left them there. So they've been there for years. This is another well bore measurement that I was involved with, another winch system, and it was up near the North Magnetic Pole in this area here. and we brought it in on a jet and landed on the ice. This is lowering the thermal array down the borehole. It went 800 meters into the seafloor and then transmitted back the temperatures over several years of the permafrost. It froze back in around the drill collar and the drill hole, because it's rather important that if it doesn't, they'll fall over eventually. And right now, I'm quite concerned about it because with global warming, the permafrost is melting, and there could be an issue with that one too. That's actually a photo of it mounted in the oil well, in the borehole, and it actually did have oil in this one here. They hit oil at and capped it off at 1,000 meters down. That's why I can only put 800 meters down the hole. And this was an acoustic system left on the ice to float around and listen for the information coming back. Let's see, I've received a Premier's Award for Technology for Canada's first fuel cell assisted sailboat, right here. We led into building of conversion of gas engines to electric to run the dinghy, a little yacht, the sailboat with its twin motors there, and the one on the lower right, that's about a 12 horsepower electric going along, and it ran quite nicely. That same fuel cell that was in the sailboat was used to run a heat pump system, which actually doubles the efficiency of it due to the using of the hydrogen and converting it into electrical power. You get a lot more heat. That system then ended up in California running a cell tower system for about a year, and they wanted to have it because it was in an environmentally sensitive area, and the only other option was to put in a very noisy diesel generator. So they're extremely happy to have this, and it worked out quite well. Okay, then I got involved with the University of Victoria as the what do you call it, scientist in charge or whatever, theorist behind the dynamic satellite. There's a quantum drive, fluorescence for linear drive, using lasers to control pitch and roll, affecting the anti-magnetic materials and the external magnetic material fields acting. It virtually created a mini black hole, and all the forces fell into it, pulling the satellite with it. The students won the national championship with it, and then somebody put their finger in it and broke the system, so it'll never get launched. And this is it here. This is conversion, a totally solar powered boat. This boat here, this is my most recent undertaking, converting a 28-foot Chris Craft over to all electric. These are the two drives in it, two electric motors driving it. The normal gas structure for it, or whatever control system, is now replaced with these joysticks and display panel, and that simulates what used to be done with gas engines. These are two 17 kilowatt battery packs, which should give me about a 50-mile range with the boat as it stands, and they're lithium battery packs, 302 amp hour units at 48 volts, and there's actually now 12,000 watt inverters in there for running the motors in the boat. And here the boat is actually charging a Leaf car. So anyway, there, I'm done now. There's how do I get out of this? There we go.
And then go back to the internet.
Do I shrink this?
Nope. Go to Firefox. Click this. And then click this. Or just right there. Stop presenting.
Okay.
Oh, there we go.
Yeah.
Is that?
Wow, Jim, that was a blast through a lot of projects. It's amazing the amount of stuff you've been involved in.
That's only some of it.
Well, thank you for trimming that down. So maybe I'll lead off here. Has the Europa mission launched, and has the winch been used yet? I'm totally in the dark on this one.
Yes.
No, well,
No, well, yes. No,
it's been used in Alaska, but it's like a technical readiness level
Yeah.
situation. It hasn't actually gone to space.
no, that'll be a while.
Okay.
They have to come back and talk to us about making it even bigger than what it is now, because they're going to want to have a couple thousand meters of cable, and that gets huge,
Right.
absolutely huge. And then you have to consider all the weights that are involved with it too. So no, it's a big deal. And quite honestly, what happened there when they came to us, was that 2020?
That's 2020.
Yeah, in 2020, it was just at the beginning of the COVID problems, and for myself, I figured I was completely done with space-related projects. But they came along and said, "Can you do this?" And then when they found out that I actually had experience in this, it actually added a level of more interest because of that. Hey,
I'm gonna go. And Daniel.
okay, my crew is leaving.
Okay. Any other questions from the crew online here?
I guess one question I had, Jim, was I mean, a common theme amongst the things that you're doing is how much the winches come up in particular, and I guess I'm trying to get a better understanding of like what is it that makes them unique and so applicable for a lot of these applications. You know, if I go searching online for winches, you see lots of like ultra heavy duty winches for lifting tons of force and torque and, you know, in industrial environments. But it seems like what your focus is on and where your strength is on is in precision and in operations, both in harsh environments, but also operating, you know, in a little bit more of a precise way. Can you elaborate on that? What makes it so that you're different? Do you have competitors that are working on these kinds of winches?
Actually, I have quite a few people have copied it, what we've been doing for years in various places. You have to go back to that very first winch I talked about, the PID-03 at that mining site. Where that all started because when we first built the first one, we made it like everybody else out of steel, and two of us had to carry that around in the bush, and you had to be able to go down to 1,000 meters depth in a borehole, and I definitely did not want to carry all that weight. So that mother of invention, we went to aluminum and built aluminum winches, aluminum drums, things that complete that particular system. You can take the drum out that's in there and put in another one. There's two different drums going on. One's for testing the drill hole, which has a wire line cable on it, and the other one has a slip ring, and you send down borehole probes. And what happened is, as time went on, competitors of the company I was working for would call up and they would actually order our systems. And then later when I left, there like a lot of calls from them, would you please build this for us? So they're being used by and sold by several geophysics companies here in Canada and in various areas in the States, and that that led to that they were all manual winches, and then I got interested in trying to make an electric one that was also lightweight. And the first one that came up was for the Canadian Coast Guard for their hovercraft. Right? And it ended up using an electric outboard inside a frame to drive the system and keep it really light. And then after that, the CSW-1 was built, which again, I could pick up and carry myself. And that's the one that ended up on a lot of those buoys at the University of Washington because they're all lightweight. That led to the CSW-6 and 7 and 8 and 10. The 10 you cannot pick up and carry. It's gotten too bloody heavy. It's about, that winch you saw, when it's finished, will weigh about 900 to 1,000 pounds roughly. But it's all aluminum and it's as light as you can make it in that respect. If you were to look at that as a steel winch, it's going to be 3,000 pounds probably around that area. So people buy them from us because they're lightweight. They're sturdy. They last a long time. I do have some systems still in the field from the mid 70s. They're still out there. Occasionally, people come and get replacement parts for them. I tried to design them at that time so that if you needed parts, you could go to a local Canadian Tire or somewhere else and buy them. But that's changed now. Now there's a whole lot of parts that go in here that you have to get from specialized sources around various countries. I don't know if I'm answering your question or just leaving it more confused.
No, that helps a lot. Yeah. I think that my takeaway was that the innovation behind keeping things lightweight, especially when you're in the middle of nowhere or in a really harsh and isolated location, is key. But also keeping on the innovation with electrification and having drums that you can swap out makes it easier to be able to do things as well.
Yeah, I used to fly into different drill sites in the mountains and all over the northern everywhere with the systems to test out drill holes and that for people, you know. And again, it had to be light to go in the helicopter. But again, you saw that on that one in the Arctic where the researcher was out on the ice with the CTD going up and down. That group, I think, was in Norway. Those people. And Klein liked it because they came to us because they had been to National Defense here, saw one of our winches where they come with handles and two guys pick up the winch or four depending on the weight of it and carry it away. So that impressed them, and like I said, they've been using them ever since.
We've got Daniel with a question.
Yeah, congratulations. I'm calling in from the Yukon, so I know about the harsh environments. My question is with the next step, we're taking it into space. Energy is a real is in short supply there. What is the part of a winch where you can save the most energy, where you can gain the most efficiency?
We went over to servo systems for that, for driving it, and I suspect it's actually going to be driven by a nuclear pile. Ulysses was a nuclear power source unit. That's why it lasted so long. All right, I forgot to mention, with Ulysses, it was supposed to go to Jupiter, get a kick, come back to the sun, go around the sun, and leave in a polar direction, and leave our solar system just like the original. What do you call it?
Voyager. Yeah,
like Voyager. And it would have been the first one to go in that particular route because of the anomalies that occurred. The whole plan was changed. It was sent back to Jupiter, and when it got there, did its thing, confirmed the results. On the way back, it ran out of fuel, so it's now in orbit around the sun. It's going to be there for a while. For myself, I have 5 different systems that have gone or are going into space up till now. I did the first 3-component magnetometer systems for the Black Brants, which were used in the sounding rockets in the Auroras to give you the true position of the rocket as it was going into the Auroras, so you could get more information out of it. That was built. I built it for NRC on the weekends. They gave me a special little laboratory in the back of a library. You opened books. You opened up the door on the books, and in behind was a little machine shop where I'd go in there and work on that on the weekends, build these things, and then they got launched. They went into space. They came back. All 3 of them landed in Hudson's Bay, and were all successful. And the technology was then sold to Darien, I think it was, in the States, and ended up in cruise missiles and God only knows what. But the one that was really interesting for me was that fluoride I discovered on my gold mining property being an anti-magnetic material. And I mean, that's something that I don't know if you guys were aware of it or not, diamagnetism at all, but
Haven't heard of it. No.
yeah, well, when I first brought it up in NRC, I got a lot of criticism, but then when I proved it in the early 2000s that it was true and that it worked, I got an awful lot of apologies from a lot of scientists afterwards. Because
Nice.
here was something that if the linear drive theoretical model works, can approach near the speed of light, it is just something completely different. But we'll see.
Interesting, Jim. Well, if we don't have any other questions, maybe we'll wrap it up there.
You're all invited to drop by anytime you like.
I think I might, because I live quite close by. I'm in Vic West here, so.
You see, you're up in the Yukon right now?
Yes, in Whitehorse.
Oh, okay. Maybe some of those De Beers winches are near you.
Maybe. Yeah. Do you ever come up here?
I have been there a few times, yes.
Okay.
But I'm getting kind of old and not traveling that much. I'm trying not
see.
to. I mean, my last big trip was the one to Greenland.
Okay.
And,
Well,
I'm-
it's pretty easy these days to come here with Air North. They have direct flights from Victoria,
yeah,
so it has become easier.
I want to spend some time on my new electric Chris Craft.
Okay. Okay. Have fun with that.
I am.
Jim, thanks again for the presentation today. Yeah, learned a lot.
Yes, thank you, Jim. It's good to see you again. Thank you for the
Thank you.
presentation.
You're welcome.
Thanks.
And maybe someday we're going to hear from the Jet Propulsion Lab on that gravity meter. You never know. They still have
Here's
it.
hoping.
Yeah, it'd be nice.
Bye for now, all.
Bye bye.
Hey,
Thank
Thanks,
you.
everybody.
Take
Bye.
care, everyone.
Thanks, everybody. Bye.
Bye-bye.